Bonds, what we see from major companies is that bonds are the lowest cost way to get large amounts of money. And in some cases, it's the only source to get large amounts of money. Here's an example of Union Pacific borrowing $500 million. It's not very easy for a bank to walk down to your friendly commercial banker and say, I want $500 million. They go to the bond markets and sell it to institutional and individual bondholders, and they raise their money. In this case, they raised $500 million with a bond of 4% notes. Now, let me pause here and just warn you that we're about to enter some choppy water. I find from my experience that students and normal human beings have a hard time with bonds. So I'm going to explain in a way separate from the book how bonds work. Put your thinking hats on and let's go on to some choppy water. Bonds, they're complicated, but I believe everyone can understand them. And I have years of showing this, so let's not prove me a liar. First, what is a bond? A bond is a contract that obligates the company to make regular, predetermined interest payments and pay all of the amounts on the maturity date of the bond. That's really what it is in a sentence, right? So each of those words and phrases means a lot. We're going to break apart each of those relevant words and show how it works. Let's say we have a company, Halt Widget Company, and we need money. We will engage and hire an investment banker who's expert in the capital markets, and we'll engage them in some corporate finance services. In the vernacular of investment banking, a corporate finance person is not someone in the corporation, it's someone who represents the interests of corporate clients to do financing. It could be stocks in an IPO, could be stocks in a subsequent offering, or it could be bonds. In this case, we're going to look at people who are expert at issuing bonds. There are 5 essential terms for the bond. You need all 5 of these or don't bother. First, what is the principal or face amount? An example here might be $100 million that we're trying to raise. Second, what's the interest rate? Now, it's not just any old interest rate, it's the coupon rate. Coupon is what is the rate that the company is obligated to pay under the terms of their offering. In this case, we'll use 12% per year. What is the interest payment frequency? Do they pay monthly, quarterly, annually, semi-annually? And the typical is semi-annual, but easier to understand for us, say, would be an annual. Date of issuance, that's the date the clock starts ticking owing you interest. Third, or fifth rather, is the maturity. When is it due? And in this case, when is 100%, it's not 10%, when is 100% of the face amount due? An example might be 5 years. So now we have the 5 essential terms. The amount borrowed, or face, $100 million. The interest rate, or coupon rate more specifically, in this case 12%. The interest payment frequency, in this case annual. The date of issuance, like the first day of the bond, January 1st in year 1. And the maturity, let's say in 5 years. So now we have the necessity for computing bond prices. Now they issue the bonds. So step 2, the market sets the price and the money moves. The investment banker made their best effort to estimate what it would take. And it's the 100 million, 12% annual, January 1, and due in 5 years. But the market might have a different idea. Notice here that cash moves when the market will accept it. They will pay what the market thinks this contract is worth. And they might say, well, for this amount of offering of cash flow, we're willing to accept the par value, in this case 12%. Or they might say, no, I think your risk is greater than what you're saying, so I need a higher rate of interest. In that case, they will pay you a lower amount of dollars than asked to get the promised amount of payments from you. That is the mechanism for what's called a discount bond. They don't take the 12% and make the 12% coupon rate go up. Instead, they say, we'll take whatever your promise is for cash flow payments, which are the coupon payments of interest and the full amount at the end of the 5-year term. But instead of paying you face value or $100 million, they'll pay you something less. The effect of paying you less makes their yield go up because they're now earning more money because they don't have to pay the entire $100 million. Now, the flip side could also be true. They might say, oh, I love your credit, and I would take a lower interest rate. They will fight with other people and say, how much will we pay? And it will settle out at a number lower than the face amount because they're willing to take the coupon payments of the annual, in this case, payments, and the $100 million at the end, and believe it or not, pay you more money than $100 million for the right to get that stream of payments. And what we call that in bond lingo is a premium. We'll do numeric examples in a moment. We're going to do a little bit of time value of money here. Some of you may have seen this before, others this will be first time. And I'm going to show you kind of the cash flow and then a way to calculate the time value of money using Excel. First, here's our example, and I changed the example a little bit here to illustrate something different. It's a 100 million bond and it's 8% coupon. First thing to notice is that the regular payments, let's say 5 years, at the end of every year, in little blue bars here, is the coupon payment. Coupon payment equals the coupon interest rate, in this case 8%, times the face amount of the bond. I'm being very precise with the words here. Coupon interest rate and face amount of the bonds. Remember that, all right? The coupon rate is 8% of 100, or 8. So imagine the height of this bar is 8. And then the amount that's paid at the end of 5 years is the full face amount, in this case $100 million. If we can draw a picture, we could put it in an Excel sheet. Here we have years 1, 2, 3, 4, 5. We have interest payment of coupon rates of $8 million per year. And at the end of 5 years, we get the full 100. On that last day, we'll get both the interest payment of 8 plus the full amount of 108 total. The present value factor, again, this may be new to some of you, is not a difficult factor. It's 1 divided by 1 plus the interest rate. Let's say that the market doesn't accept 8% and they need 9%. The factor here would be for 1 year, 1 divided by 1 plus 9%, and that is 0.917. Now, that means dollars we receive a year from now are worth 91 cents today. Now, if we go out to year 2, we have to wait longer, right? We have to wait 2 years instead of 1. So the way we do it mathematically is the same idea. 1 divided by 1 plus the interest rate, this time raised to the second power because we're compounding it for 2 years. So that leads to a smaller number, 84 cents. That means a dollar 2 years from now is worth 84 cents. When we move to year 3, guess what? 1 divided by parens, 1 plus the interest rate, close parens, raised to the third power. And guess what it is for the 4th year? 1 divided by parens, 1 plus the interest rate, raised to the 4th power. 5th year, same thing. I won't even insult you. It's raised to the 5th power. So just going out to this outside year, $1 5 years from now at a yield of 9% is worth 65 cents. So that's how much I'm willing to pay you. If I'm going to get $8 million from each of these 4 years, I can discount that back at what a dollar's worth for 1 year from now, for 2 years from now, for 3 years from now, for 4 years from now, and the big one, 5 years from now, and multiply those factors times those cash flows. 1, 2, 3, 4, 5 years. When I add all those together, I get the price of the bond, which is $96. So stepping back for a moment, this bondholder said, I will not accept 8%, I need 9%. So rather than have the company adjust all their paperwork for their bond, instead the company's going to pay what it promised to do, 8% of $100 million or $8 million a year for each of the next 5 years. And at the end of the maturity of 5 years, I'll give you the full $100 million. The bondholder then says, okay, great, with this cash flow at my required interest rate, I'm willing to pay you not 100, but $96.11 million. All right. So I'm going to hop into Excel just to show the math in Excel. So it's exactly the same thing. I've got this table, and I want to show you these calculations. So it's 1 divided by, open parens, 1 plus the interest rate, here 9%. Notice the dollar signs, that makes it an absolute reference, so I can copy it safely. Raised to the power of number of years, raised to the power of B15. Notice no dollar signs there. So as I copy this formula across, the locked-in rate would be there, and also the years would increment. Because as I described the formula, every year further out, you move up the power to which it's raised. So if I copy that, I will see here, we locked in the interest rate and it's scooted over to number 2. When we move all the way to year 5, guess what? Same thing. We locked in the interest rate in cell A21, but we allowed the years, the exponent to increment from year 1 to 2 to 3 up to 5. Then the multiplication is easy. It says if I get $8 million in year 1, and if each dollar is worth 91 cents, then that $8 is worth $7.339, right? Same thing all the way to the outside year. If $1 is worth 65 cents, then $108 million is worth the 0.65 times that amount, or 70.19. That sum equals the value or the price of the bond. So I'm willing to pay $96.11 million for $100 million of bonds stated at a coupon interest rate of 8%, and the cash flow from all those flows, annual flows and the year 5 flow, makes the whole system worth 9% to me. That's how the bond market works. They fight between the buyers on what will they pay for this particular offer of cash flow, right? All the bond is this offer of cash flow right here. I'm giving $8 million a year plus another $100 million at the end of 5. And they're saying, what will I pay for it? This case, I will pay $96 million if I need a rate of 9%. So a little later, I'm going to show you the Excel formula as well. But for now, let's not make things too heaped up on you. We have a cash flow. The cash flow becomes a set of numbers leading to one row of specific dollar amounts that will move from the bond issuer to the bond holder. We then do the present value calculation for what a dollar is worth for years 1, 2, 3, 4, 5. Then we multiply it to get what each of those flows are worth individually. And when we add them all together, it is what each of those flows in total are to the bondholder. And that is, by definition, the price of the bond.